Let's talk about something you probably see almost every single day, but maybe don't think twice about. Clouds. Because it turns out they're hiding a pretty massive paradox. And really, it all comes down to this one question. I mean, you look up, you see them just drifting by, looking like they weigh absolutely nothing. But the science? Oh, the science tells a very, very different story. Okay, get ready for this number, because this is what starts the whole mystery. Your average, run-of-the-mill, puffy white cumulus cloud weighs, wait for it, about 1.1 million pounds. Yeah, just let that sink in for a second. And that's where you get this wild disconnect. What our eyes see are just these fluffy, weightless puffs. But the reality is the weight of two gigantic Boeing 747s just hanging out right over our heads. So how is that even possible? Why isn't all that weight just crashing down? Well, to crack this case, the first clue isn't looking at the big picture. Nope, we have to zoom way, way in. Because the secret, it turns out, starts with the power of being incredibly tiny. You see, a cloud isn't one solid thing. Not at all. It's actually a massive swarm of trillions of individual microscopic water droplets. So think less like a bucket of water and more like the finest mist you can possibly imagine, just on a gigantic scale. So, just how tiny are we talking here? Well, the average cloud droplet is about 20 micrometers across. And yeah, that number is kind of hard to wrap your head around, so let's put it in perspective. Okay, so think about a single human hair. The width of that hair is around 70 micrometers. That means one of these cloud droplets is less than a third of that size. We are talking seriously, seriously small here. And that right there is a huge part of the answer. Because these droplets are so minuscule, they have a ton of surface area compared to how little they weigh. It basically gives them their own tiny parachute. Air resistance has a huge effect on them, which means gravity just can't pull them down very fast. They do fall, but so incredibly slowly. Okay, so they fall slowly, but that's not enough to keep 1,000,000 pounds floating in the air, right? There has to be something else. And there is. A second, much more powerful force is at play here. These droplets aren't just falling, they're also riding an invisible elevator going up. So what you have is this constant battle happening in the sky. You've got gravity trying to pull these tiny droplets down, but super slowly. And then you have warm air rising from the ground, an updraft, and it's constantly pushing up. And here's the key. As long as that upward push is stronger than gravity's gentle downward tug, the cloud just floats. I love this way of thinking about it. A cloud isn't just sitting still. It's in this constant dynamic state. Every single one of those trillions of droplets is essentially treading water in an ocean of air. It's working to stay up there. All right, so we've got two pieces of the puzzle. Tiny droplets that fall slowly and an updraft pushing them up. That explains the little guys. But what about the cloud as a whole system? Well, for that, we need the third and final piece of the puzzle. And it all comes down to the secret of buoyancy. Now this next fact might just blow your mind. If you could take a chunk of a cloud, say a box about 3 feet on each side, how much actual water do you think would be in there? The answer is, on average, only half a gram. That's it.
So what does that mean? It means a cloud is mostly empty space. It's almost entirely air, with those trillions of little water droplets spread out super, super far apart from each other. So even though the cloud is enormous, it's surprisingly not dense at all.
And that leads us to another perfect analogy. The air inside the cloud is often warmer and more humid than the air around it. And what does warmer, less dense air do? It rises. So the whole system, the air and the droplets together, becomes buoyant. Think of it like a giant hot air balloon, not a water balloon ready to pop. So you have these three forces all working together: the tiny droplets, the powerful updrafts, and the overall buoyancy. It's this beautiful, delicate equilibrium that keeps 1,000,000 pounds of water floating. But, balances can break. And when this one finally does, well, that's when things get interesting. So let's put the solution to our paradox together once and for all. A cloud is incredibly heavy, for sure. But it floats because, 1, it's not a solid thing. It's trillions of microscopic droplets. 2, those droplets are being constantly pushed up by rising air currents. And 3, the whole system is buoyant, acting just like a hot air balloon. That delicate balance finally breaks when those tiny droplets start bumping into each other. They collide, they merge, and they grow bigger and heavier. And eventually, they get so heavy that the updraft just can't hold them up anymore. Gravity finally wins the battle, and that, my friends, is what we call rain, the million pounds finally coming down. It's pretty amazing, isn't it? Something as simple and everyday as a cloud is actually this incredibly complex, dynamic system hanging in a perfect balance. It's a powerful reminder of all the invisible forces at play around us, all the time. And it kind of makes you wonder, what other massive, invisible forces are out there shaping our world in ways we never even think to question?